Good afternoon, everyone. My name is Vicky Denton, and I'm your host today. Welcome to the ALIA webinar on turbine oils. Our presenter today is Chun Noi Lim. Chun Noi is with Afton Chemical, and she is in charge of industrial lubricants. Before I introduce her, I'd like to talk a little bit about ALIA, the Asian Lubricants Industry Association, which is producing this webinar on behalf of its members. So you'll see on the screen that we have about 5 key objectives: advocacy, knowledge, networking, professional development, and sustainability. I'd like to introduce Chun Noi. She's no stranger to many of you, as she had presented in the past. Chun Noi is the Customer Technical Service for Industrial Lubricants of Afton Chemical Asia. She provides solutions to customers in Southeast Asia, Taiwan, and Korea. Chun Noi has a BS chemistry degree from National University of Singapore. Her career's focus has been on industrial lubricants. More than 25 years in the lubricants industry, most of it with Castrol and BP lubricants. She has held various positions in laboratory, R&D, product development, marketing, customer, and product portfolio management. I would like now to turn over the platform to Chun Noi so she could start her presentation. Chun Noi, welcome to the webinar on turbine oils.
Thank you, Vicky. I'm very happy to join you this afternoon for this session on turbine oil. Yes, good afternoon, everybody. I'm Chun Noi. I am presenting this topic on behalf of Afton Chemical, and I'm very delighted that you can join me this afternoon on the session. All right. My topic today will be covering these key areas. It will be primarily on what is the industry in turbine power, where is it majority focus, where are the focus area, what are the type of key turbines, and we're covering another section on the turbine oil requirements, the technology, and finally I'll wrap up with what is why we need a good well-formulated turbine oil. Okay, so if there's any questions, I would appreciate that. Maybe perhaps we can leave it to the end as a Q&A session. Thank you. Okay, in the current era, 2021, we have a situation where we demand power in many areas. And you can see that from the chart here, the global consumption measured up to 2018 is on the increase, but forecasted to 2050, okay, is also forecasted to increase, and is more, the growth is more on a particular area, which is the natural gas. And this is natural gas and renewables. So this is tied in with a lot of the current interest in renewables, in providing a more sustainable earth, in the earth that we stay. So you can see that with this kind of energy consumption increasing, there are two things. One is that the hardware need to catch up with this kind of growth. Another one is that whatever that is supporting the hardware also has to correspondingly support this growth. So another area where we can see energy consumption increasing is the data platform, right? We can see that the current webinar that we are on, the power that we need from the data centers that are supporting all these platforms of webinars are all supported by, are all needing the power to move ahead. So you can see that there's an exponential growth in the demand for power center, data center, that all this growth comes primarily from the internet user use of the internet platform. Now, what we have seen just now is one area where growth is happening for power. Now, what are some of the supporting areas that where we see the drive for all these changes? Okay, on the right side, on the top right, you can see this is related to safety and environment. Environment is a very strong factor. The sustainability of the earth, sustainability of areas that we talk about, use of the resources, okay, growth in energy demand, definitely. The changing use of the base oil, group 2, group 3, there's a shift from group 1. And also in the way the OEMs support this growth by having new equipments, by having more powerful equipment, more efficient equipments. And also in the case of the manufacturing, where are the growth areas because of the migration for manufacturing sources. So pockets of growth in different areas are happening, and all this means the demand for energy will continue to increase. Right. And we have at the bottom of the screen here, we see that some of these factors are mentioned, will be mentioned later, is actually based on the end users' feedback. And these are currently key areas that Afton is also focusing on to support this type of growth. Now, what are the turbine markets and turbine producers? Right. So you can see from the graph here, GE predominantly have the major platform of this gas and steam turbine. The next one is followed by Siemens, and subsequently the MHPS, which is now called Mitsubishi Power. So being the dominant supplier of such OEMs, it's obvious that they are taking a very strong leading role in making of their turbines more efficient, more sustainable, and more durable, as well as more long-lasting. And in doing so, they need to be supported by, of course, software, of course, all the other peripherals, including the oil that lubricates the equipment. And this is where turbine oil comes in as a very strong factor to support this sustainable growth. Okay, how many types of turbines are there? Primarily, they are divided into 3 for the discussion this afternoon: water, steam, and gas. And you can see that there is a big difference in each of this, and the gas on the right column, which is actually having the highest speed. And the speed is important in this case, where it generates the power. Okay, so speed comes along with temperature, with the sun in the oil, and of course the hot peaks. So contrastingly, you can see that on the gas turbine, all the parameters that are listed are on the upper end as compared to the other 2 turbines. And so the severity of operation in a gas turbine is definitely a lot more in terms of demand, and therefore in the demand of the lubrication process. is also higher. That also explains why in the gas turbine, the service life is usually shorter compared to the other two turbines. And that is a very strong factor in saying that when we have a combined system meaning a steam and a gas system operates together. And obviously, with a gas having a higher demand in operating conditions, this will also drive the combined system into a higher requirement. Okay, so what are the requirements in the turbine oil, and how are they differentiated? Okay, just let me share with you here, okay, the OEMs that are playing a major role in providing turbine oil specifications. Turbine oil specifications defined by these OEMs are used for their own turbine. All right, and the turbine that they are making could be a steam, could be a gas, and they have this turbine oil that spells out what is required in each of these turbines. On the right hand side, you have these industrial specifications, which are non-OEM defined, but are industrial standards from ASTM, from the British standards, from the German standards DIN, ISO, Japanese standard JIS, China, GB standards, and US militaries. So these standards will define the type of oil that is required to operate in a certain type of turbine. Right? There are other OEMs that do not define turbine oil, but they do also use these specifications, especially the industrial specifications, to guide the use of the turbine oil. Okay, now a quick look at what are the GE, since GE is the major turbine OEM supplier. And from here you can see that those highlighted in blue are the steam turbine specifications that relates to steam turbine, right? Those in black could be either gas or a mixture of steam and gas. Right. If we look at the revised date of these specifications, you can actually see that in the listing here, there are a couple that are very recently revised in 2018, 19, 2000, 2001. All right. One of the key specifications that are leading this current change is the combined cycle, which is reflected on the GEK 121608. You can see that in this specification is defined as having a combined cycle steam and gas. So in order to meet this requirement for a steam and gas turbine, you do need to meet the gas turbine, which I have in my earlier slide I have shown that it does have a much higher requirement in terms of operating conditions. So naturally, when we look at this specification, the GEK 121608 will definitely have a much higher requirement than just a single steam or gas turbine. Okay, so we'll go into a bit more details on the turbine oil. In particular, you can see that all the lubrication does not only include the turbine, it includes accessories linked to it, which is like the bearing, the gear. And so therefore there are turbine oils that require the EP, extreme pressure additives that needs to be lubricated as well. In the turbine oil specifications for OEMs, the other OEMs like Siemens, MAN, Solar, Mitsubishi, and Soldo, these are also OEMs that have their own specifications as defined, and they can be shown here listing in the listing here. And also in one area is that they are sometimes divided into gas and steam with different operating conditions. For example, in the case of Siemens, they have two specifications, and one covers the higher temperature and one covers the normal temperature. So in this case, a product, a turbine oil that meets the higher temperature would naturally meet the turbine requirement for the lower temperature or the normal temperature, but not the other way. So it is important that when you do the selection of the turbine oil, it is a suitable turbine oil for the type of equipment as well as the condition of the equipment. Okay, so the next page here, you can see that these turbine oil specifications are covered by industrial organizations. So they are non-specific to any OEM, but some of the OEMs have adopted them as the basis and then add on other requirements. All right. So again, each of these specifications does cover the different conditions. All right, whether it's normal standard temperature or the higher temperature. So for example, you can see in the DIN here, they cover two different temperatures, the standard and the high temperature application. All right. And in the ISO, there's even a range that covers the combined cycle turbines. So it's not just the OEMs that defines the specifications for a turbine oil, it's also the industrial organizations that defines that type of turbine oil. So what goes into a turbine oil to meet these requirements that are spelled out by either OEM or the industrial specifications? Okay. You have seen just now from the requirements that turbine oil lubrication is about the equipment. It's about the whole system, not just the turbine alone. So highlighted here in green, you can see that the requirements of a viscosity of a gas turbine, as an example here, the viscosity would be an ISO VG 32 and 46. Usually it's not higher, it's usually on these two viscosity grades. And moving to the left, you can see that this requires a good oxidation stable turbine fluid. It also requires it to be protecting the metals. All right, corrosion and rust protection. All right, and of course, bearing protections are also covered here. Now, another characteristics of this turbine oil requirement would be the surface characteristics, we call them, which is things like good air release property, good deform property, as well as metal protection. So when we say good air release property, this is actually a property of the base oil, and it is important to choose a good base oil, very stable base oil, to work with. All right. And also when we talk about lubrication, we do not foam and air do not lubricate well. So we need to have good selections of fluid that is having good demulsibility, good foam control. All right. So to sum up, this lubrication of the turbine oil, it covers also bearings, it looks at gearbox, it looks at the seal protections. All right, so in looking at the turbine oil, when we talk about this lubrication, we do need to consider where are these properties embedded in the turbine oil. Okay, so this is some summary of what I have just mentioned in the case of a turbine oil requirement. All right, two key properties: good oxidation, strong metal protection, whether it's metal on steel, metal on copper or bronze material. All right, good air defoam properties, and good selection of the base oil that is compatible with the additives in the system. Okay. Now, when we talk about turbine oil, the impact of the base oil cannot be ignored. All right. So when we have this type of base oil in Group 1, Group 2, Group 3, Group 4, when we talk about mineral-based turbine oil, we typically look at Group 2 or Group 3 coverage that is suitable as a mineral-based turbine oil. All right, and Group 2 and Group 3 are the prevalent source and the preferred source of formulation with turbine oil. All right, due to their nature of being very thermally stable and being having good compatibility with additives formulation. So in the arena of turbine oil, preference is Group 2 or Group 3. And currently in market, Group 2 has a very high accessibility, reachability, availability, pricing, economics. So it tends to be a prevalent source. Okay. So this is an overview of where we look at in terms of why we choose Group 2 and Group 3. All right, in a Group 2, all right, we find that it's better in response to antioxidants. All right, good synergies with antioxidants, and also good oxidation life measured by torch. This is an oxidation test, and it's also have a good air release requirement. So the preference of the base oil is also due to the base oil properties that are developed with the base oil. All right, another area that as an additive supplier, we find that the importance of selecting the correct base oil or the appropriate base oil is also to cover a very important area, which is in oxidation specific to turbine oil, which is the varnish or deposit formation. And this is a measurement of oxidation. All right, this is the oxidized product, but quite specific to turbine oil. Okay, it's a pictorial representation of what goes into a turbine oil. And you can see from the number of stars here, the antioxidant and the rust inhibitor are the key components inside the turbine oil. So naturally, as a major component in the turbine oil, right, they would be the most carefully considered and selected chemistry as well as functional properties to match the type of turbine oil. I mean, others like anti-foam, which could be complementary to the function if it is required. Right, so just go into a little bit more on the technology of the turbine oil. What is included? Well, we know that antioxidant plays a very, very important part. So when we talk about antioxidant, we talk about free radicals. It's just like in the human process, we talk about aging. But in this case, in the case of a turbine oil, we also talk about aging of the oil. We also talk about oxidation of the oil. But there are byproducts that are being formed, which is typically listed as varnish or sludge, right? And in this case, the varnish or sludge will form a coating on the metal surface and interfere. Okay, so this has a negative effect because it's a chain reaction. Once you have an oxidation starting, it will cause more oxidation to start. All right, and this increases not only the acidic component, acid content, it will also cause a lot more issues like cross-linking, like chemistry of the oxidized material affecting the current fluid. So these factors would enable the turbine oil to cause the turbine oil to have a shorter lifespan, and therefore this sludge or varnish, the longer it takes to be in the system, the worse the turbine oil is. So it's desirable to have the turbine oil having oxidized material as late as possible. All right. So therefore having a longer life for the fluid. Okay, these are typically the type of antioxidants that are used, right? And there could be many permutations and combinations of the antioxidants possible. And in this case, they all have the same function. Primarily is to stop the oxidation, the free radical from forming, and the free radicals to be captured and trapped over the lifespan of the fluid. Okay, what is varnish? Varnish is just a deposit, right? That is formed during oxidation. And from the screen here, from the picture here, you can see that they are deposited on metals, and they actually cause sometimes static discharge on the metals. So these are not desirable, and these are preventable to some extent. At the current moment, these are only measured based on the fluid in use. They take measurements of fluid in use to see the level of oxidation or the level of varnish. And that is a completely whole new subject by itself. Okay, so in the formulation of a turbine oil, when we measure oxidation, this is measured in the laboratory condition. You can see that this is just using an illustration from a GEK specification. Right, there's different types of oxidation tests. There are a few listed here only. Tosh is one of them, And torch is a very extensive test. The torch test requires the test to be having the tubes shown on the picture here, the coil immersed in a fluid and subjected to the oxidation for as long as up to even 7,000 or more hours. So you can see that in the process of developing this product, okay, the specification requirements being so high, it actually takes a very long time to make sure that the specs are met and it is actually achievable. Another test that is commonly used, which is a shorter test, right? The test is RPVOT, which is measured in minutes. Obviously, this is much shorter, but you can see that in the case of the RPVOT, it's also reflecting the higher requirement. The higher RPVOT reflects the higher requirement in the oil. Okay, I'd like to draw your attention to these two extremes here that says combined cycle. This oil here is meant for a combined cycle turbine system. And you can see that in this list of specs, they have one of the highest requirement. All right, and also in the case of gas turbine, this 107395C is for a gas turbine. It's also having this high requirement. So to formulate a turbine oil that meets this oxidation requirement, just in the laboratory, just in the design stage, is a very extensive process. And that's why a lot of effort and focus is spent on selecting the suitable and good antioxidant. So when we say we do the selection of antioxidant, one of the things that we want is for the antioxidant to last a very, very long time. Okay, and to last a very long time in this test, the interpretation is that this induction period, if you look at the graph on the bottom right corner here, the induction period is very long, right? The longer the induction period, okay, the higher or the more stable the product is, right? So obviously, if you have a shorter induction period of this turbine oil, that when you test it, the oil is less stable compared to one that is having a longer oxidation, longer induction period. The same applies for the two methods, torch method as well as the RPVOT method. The other test that is pretty important because of the metal protection would be the corrosion inhibitors. And when we talk about corrosion inhibitors, we talk about two types of surface phenomena. One is for rust, for iron. Another one is for copper or copper alloy materials. Right. So what it does is that the copper, the corrosion additives, anti-corrosion additives, forms a protective layer, okay, on the metal surface, and therefore by doing that protects the metal. And in this process, the metal is actually in a way protected because of the chemistry of these corrosion inhibitors that are covering the metal surface. So a good selection of this anti-corrosion, anti-rust, anti-copper deactivator material are very important. So this is a very specific example of protecting copper surface or any copper or copper alloy material, and so it's actually forming a protective layer on the surface. Right. In terms of when we do physical tests, this is what we see. The picture on the right and the picture on the left. Right, it shows the fail where rust is seen and the pass where there's no rust. So this test is subjected to two conditions. One where there is seawater and one where there is distilled water. Obviously, the corrosion is more aggressive in a seawater, where you can see that if it passes a synthetic seawater spec, it will definitely pass a distilled water spec. So the importance of this is that because where turbines are used, especially in a steam turbine, where moisture is present, the water vapor is present, or even hydro turbine, so corrosion has a tendency to set in if it is not having good turbine oil to protect this metal surface. Okay, summarized here are the key properties of a turbine oil and what are the tests that are typically used in defining these properties. Of course, there are much more tests than this. It depends on what is required in the specifications, but primarily we have oxidation, metal protection, we have water separation, we have deform property, so that we are lubricating with oil and not air, and also the good air release property. So you can see on the screen here where oil and water is separated. This is critical, especially in a steam turbine, steam or even in a hydro turbine, where water or moisture is in play. So with these key properties of a turbine oil, we can see that in formulation of a turbine oil, in choosing the turbine oil specifications, in guiding the design of a turbine oil specifications, the selection of the components as well as the formulation of the package in a turbine oil, all the factors has to come into play, and all of them has to be synergized to give you a good matching turbine oil for the respective function. Right? So when we talk about the function of a turbine oil, the benefit of having a good turbine oil, we say that this turbine oil must cover this few, at least the key parameters. Okay, going from the right would be the oxidation stability, which is a good oxidation stable, long life, sludge in the form of a varnish in particular, and good filtrability in the case of any contact with water, rust and corrosion inhibition, protects the metals, and good water separation. So in the case of formulating a good turbine oil, we do say that the factors represented here have to be maximized. The number in digits represents the property. The higher the property, the better. All right. So especially in the case of the oxidation, it definitely have to be a very strong oxidation stable product to be in a turbine arena. Okay, and we talk just now. We talk about being a long induction period. Now, inevitably, turbine oil will deteriorate after use. Up to a certain time, it cannot be perpetual. It cannot be forever. So in this case, the technology in formulating a turbine oil would be to make this stretch as long as possible. This blue curve that you see here, okay, to last as long as possible before the oxidation sets in. When oxidation sets in, oil degradation, free radicals formation, chain reactions happening. So this will accelerate the oxidation process almost immediately, if not instantaneously, catalyzing more reactions to happen. So modern turbine oils, as we call them, we look at meeting combined cycle turbine oil, and combined cycle turbine oil is even more important that both the combined cycle, the steam and the gas turbine, are well lubricated to give the good combination of this combined cycle lubrication. Right? And when we start looking at the properties of this turbine oil, we also realize that why we need good turbine oil or effective lubrication, because this is talking about service life overall in a turbine. And in a service life, the longer the service life, the more value it can bring to the user, to the operator. And the longer the service life, the less downtime. Okay, so in case of any performance of this turbine oil, it has also have to be managed during the life of the turbine oil, meaning that normally there's a program to follow up with this turbine oil monitoring during the lifetime of the turbine oil. So having a good turbine oil to start with is not just the end of the story. You do need to combine with a good program for the service life. Okay, so when selection of a turbine oil, when we look at this turbine oil as a performance fluid, right? Selection of base oil, availability of the base oil, and availability of this fluid to provide the above effective service life is very important. So this is where for additive suppliers like ourselves, we will be looking at this to maximize the economics of a turbine oil. Okay, so the growth of steam and gas turbine in summary is actually forecasted at 2%. All right, and this is because of the need for power and the demand for power. All right, and all this demand for power means that in the future, the newer turbines will be designed with combined cycle more than just a single cycle, and increasingly use of more efficient turbine oils requires better turbine oil to support the system. Okay, so for turbine oil, when we look at operators, the operators focus on using the equipment for the most efficient life of the system. And OEMs are focused on designing equipments that provides efficiencies. In the current efficiencies of the combined cycle is in the magnitude of the 60%. And this is definitely going to improve as the technology of equipment improve. So likewise, the importance of selecting the correct or the good turbine oil is complementary to all these processes to provide the very strong support for this industry. And that is the last page of my presentation. All right, thank you very much. If there's any question, I'm happy to take it.
Thanks, Chunoy. Really very informative, very technical, I may say. So we have a question here from Pertamina, from Nuruddin. So the question is, several brands of turbine oils are facing foaming issue, about 400 mils of foaming tendency. But then after hiring third-party filtration company, I'm not so sure about the second bit, but the question is, do we have any limitation from additive companies for the minimum filter micron rating to be used?
I think the question, if I may rephrase, is that there is a foaming issue.
Yes.
And they are using filters,
Yes.
right? And whether there is a certain filter size recommended from additive suppliers. Yeah.
Yes, to lessen the foaming tendency. Yep.
Yeah. I think I would approach it from the angle that to understand what is the cause of the foaming rather than the filtration or filterability of the fluid. Because obviously you are looking at a used fluid. Yeah. Am I correct to say that this is a used fluid?
It's not clear, Chunoy, but probably let's just assume it's in used fluid. Yeah.
Yeah, if it is a used fluid, I think it's important to make comparisons with the new fluid and understand possible areas that the foam could be arising from. Because I'm unable to provide you what kind of filter is the right filter size because we are not the filter experts in this area. But certainly to look at more of what is driving this formation of this foam and look at the possible angle that how the foam formation and what can be done about the foam formation.
Chunoy, maybe I can invite Nuruddin to probably check if that answers the question or if there's additional follow-up question. Nuruddin, would you like to?
Can you hear me?
Yeah, there. Yes, thank
Okay, thank you for allowing the microphone button to on. Yeah, we face this issue for several brand of oil that they told me it happened due to they just hiring third party company to clean their oil in order to get the ISO cleanliness level that expected by original equipment manufacturer. So because nowadays we found in a lot of literature, most of consultants are recommending that more clean your oil, that means you will get expected more oil life or better reliability. So the people try to clean the oil uh, as good as they can, and um, in some cases I get information also that they are using 1 micron filters that when I take a look at the a manual book of the most of lube oil system company, uh, mostly using a filter about 10 to 40 microns. So using 1 microns filter in order to get the oil to be clean, I just worrying. I worry if it will able to filter the additive as well, and that's why we are asking here that is there any limitation uh, of microns to be used in order not to filter the additive.
Okay, if your concern is on additives, um, additives are basically oil-soluble components. They are basically organic in nature, soluble in base oil. All right. The other thing that is added that probably has some means of partial solubility or suspension, that is anti-foam. All right. Um, but sometimes in the case of this selection of the components, all right, the best type of anti-foam could be the type of anti-foam that works well but does not have a very fine molecular size that is very readily suspended in the fluid. So I think in this case, having a 1 micron filter, I mean, I'm not a filter specialist, but just looking at a 1 micron filter, you will take a much longer time and require probably a higher pressure to operate this system. So there would be some level of efficiency that you need to consider as well, not just the cleanliness of the fluid. And as you have rightfully pointed out, 10 to 40 micron is a typical normal what I do hear from users about the choice of micron. Yeah. So I would still think that looking back at the points that you have raised, I think it's still best to look at not just the cleanliness, but the overall system and how that can be or what has contributed to this challenge. Yeah. Perhaps if you are comfortable, we can probably discuss this further offline, if that
Yep.
is okay with you. Yeah.
Yeah, I think Nuruddin, it would be good to connect with
Yeah, it's
Chunnoy on
okay.
this one offline. Yep. Thank
It's
you.
very excellent. Yeah.
Yeah, thanks. Is there any more question? If not, can I ask a question, Chunnoy? We talked about you talked about sludge, varnish, and induction period as more or less one of the factors to be considered in terms of how much sludge formation or varnish formation. But then you also mentioned that these are only tested for the sludge and varnish for in-use oils. Is there any correlation that we've conducted in the past to actually give an indication based on the results of the induction period that will more or less predict the likelihood of sludge or varnish formation? Do you have any information or data on that one in the past?
Your correlation refers to in practice versus the laboratory.
Yep.
Okay. Now, if we look at the example that I illustrate in the GE, where they have the test that they have set up, all right, TOSH test, RPVOT test. Although these are laboratory tests, all right, there is a relative difference in the test output that is expected. You can see that the longer the duration of the test, or longer the test holds in terms of like 7,000 hours, all right, the longer the test holds, the higher the requirement of the turbine oil, which is actually gas turbine, right? So most of this gas turbine oil will have a much more rigorous requirement, as from my much earlier page. And if there is this indirect correlation already in the market, the turbine oil specs are built upon this type of specifications. So if you were to, for example, say that, okay, if you have a TOSH of so many hours, how does it link to usage in the field for how many hours in the field? Then there isn't a direct link in that case. But we also do need to remember that when we use the turbine oil in the field, in the actual application, there are many, many other factors that can affect the life of a turbine oil. There are things like contaminants, there are things like particulates, there are things that metal particulates, there are things that are non-contribution from the turbine oil that can affect the life of the turbine oil. And therefore, it's not easy to do any direct correlations, but an indirect reference would be what I can see from this specs, either from the industry or specs from the OEM that link to the long life or the durability of the turbine oil.
Okay, thanks, Chunnoy. Miss Vicky?
Yes, May. We have to wrap up in about 2 minutes, but if I may just indulge me, I'd like to ask the last question. So you mentioned a few things. Turbine oil formulation is usually about 99% base oil. And stability is a key feature, one of the most important features of a turbine oil. So my question to you, Chunoy, is how do you then decarbonize turbine oils if stability is a very critical feature? Assuming that you're using other than refined Group 2 base oil. What are the other options?
I think in this current technology is the use of well-designed type of antioxidant. Because the technology of the base oil currently is driven by base oil suppliers, obviously. The additives are driven by the additive suppliers. So in this case, when we talk about improving the durability, the long-lasting use of this turbine oil, is actually based on how well these additives work in the system as a whole.
Okay, I think it's a long conversation, and we can probably have an entire session in this. In the meantime, maybe I'd like to thank you, Chunoy, for a wonderful presentation. And maybe you can give us some highlights of upcoming events.
Yes, thanks, Miss Vicky. Thanks again, Chunoy. If you look at the screen, you would see 3 upcoming events. The next one would be part of our sustainability series, and this is going to be presented by Yvonne.